Hey guys, it's Mrs. Diaz and I'm here to show you another example with rational functions. These are going to be the characteristics of rational functions, and I'm going to go ahead and start off with my famous song. So it goes like this. Vertical asymptotes found in the denominator. Horizontal asymptotes Bobobot eats to see. X-intercepts are found in the numerator. And don't forget the holes are the ones that cancel out. And the rest is history. So use this song to help you and guide you in our first example. So let's take a look at the example. First thing I'm going to notice is if I were to distribute this x, I would really get x cubed plus 2x squared minus 3x all over x squared minus 9. And you might think, well, why did you do that? Well, I want you to notice that it's higher, degree is higher on top, and it's higher by 1 degree, which is going to be bots. So I'm going to start off with the horizontal asymptote. Wait, where's the horizontal asymptote? Oh, there it is. And this is not going to be a horizontal asymptote. It's going to be a slant asymptote. That slant asymptote is going to be because it is bots. So we're going to find that in just a minute. So now that we know it's bigger on top and it's a slant asymptote, I'm going to go ahead and do some long division. So I'm going to take x cubed plus 2x squared minus 3x, and I'm going to divide by x squared minus 9. So when we do long division, you got to figure out how many times is x squared going to x cubed. Well, that's going to be x amount of times. So x times x squared gives us x cubed. And then minus 9 times x is negative 9x. So I'm going to put a 0 for the x squared spot since there's no x squared. But then we get negative 9x. All right. And then we're going to have to subtract. But if you're like me, I like to distribute that negative. Since we're subtracting the whole thing, I distribute the negative, meaning this turns into negative, this one also turns into negative, and then this one turns into a plus. So the x cubes canceled. We got 2x squared, and then minus, or plus, rather, 6x. Then we figure out how many times is x squared going to 2x squared? Well, that's only 2 times. So 2 times x squared is 2x squared. 2 times negative 9 is negative 18. So again, a 0 for the x spot and negative 18 here. We then combine like terms by, first of all, subtracting. Remember, I distribute the negative. This turns into negative, and that turns into plus. So it looks like it's going to be 6x plus 18. Now, I really don't care about this piece. This is the remainder. What I really care about is this piece right here, because our slant asymptote would then be y equals x plus 2. All right, so we have the slant asymptote. Good stuff. The next thing I like to do is then factor. So I'm going to factor this rational function so I can figure out if they're holes or x-intercepts or vertical asymptotes. So to factor this, should probably leave it at the original format, which is this one here. I'm going to factor x squared plus 2x minus 3. That's going to be x plus 3 and x minus 1. All over, and then this is a difference of squares, so that's going to be x plus 3 and x minus 3. All right. Now, do you guys see anything that cancels? Well, I'm going to show you that the x plus 3's cancel, meaning that creates a hole. So where's the option for hole? The x value there would be what makes that 0, which is negative 3. And then I'm going to go ahead and substitute negative 3 back in for x in the simplified version so I can figure out the y coordinate. So we got negative 3 times negative 3 minus 1 is negative 4. So negative 3 times negative 4 all over negative 3 minus 3 is negative 6. So that's 12 divided by negative 6, which is negative 2. So the coordinate here is -3, comma, -2. And it looks like we only have one whole. All right. The next thing I'm going to do is I'm going to find the vertical asymptote. Remember, vertical asymptotes are found in the denominator. So in the denominator, we're going to set that equal to 0. X would have to equal 3. So there's our vertical asymptote. And then the x-intercepts, if you guys see x-intercept, that's found in the numerator. It looks like I have two of them. X equals 0 and x equals 1. X equals 0 and x equals 1. So we have 0, 0 and 1, 0. I'm going to go ahead and plot these points to figure out what I have so far. So we've got a vertical asymptote at x equals 3. Let's do a little sketch over here. 1, 2, 3. This is my vertical asymptote. We've got x-intercepts at 0, 0 and 1, 0. 0, 0, 1, 0. We have a hole at -3, -2. -3, 1, 2, 3, -2. There's the hole. And what else do we have? We also have the slant asymptote, which is x plus 2. So that's a linear function. Whenever we graph a linear, we start with the y-intercept, which is +2. And then we do a slope of up 1 over 1. 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 Down 1 over 1. Down 1 over 1. Down 1 over 1. And that's going to be kind of like this. Now remember, this is an asymptote. And you want to make that a dashed line. Okay, so far I've got the asymptotes, I've got the x-intercepts, and technically I've got the y-intercept too. The y-intercept is going to be also 0, 0. Okay, it looks like I got a few more pieces of information to find. Domain, range, continuity, decreasing, increasing, symmetry, boundedness, extrema, and end behavior. So let's try a few more things. Let's take a look at this picture. What we're going to do is to find some of these pieces like decreasing or increasing or extrema. We got to find the max and mins, and I'm going to tell you we would need the calculator. So grab your handy dandy calculator, put it in your y equals. Notice I have it in my y equals right there, and let's graph it. So it looks kind of crazy because of these crazy asymptotes. You guys see how it kind of cut off there? I'm going to go ahead and change my window. Also, if you hear the bell in the back, that's my puppy. I'm going to let him out in a minute. All right. Okay, Russo, hang on. So x minimum, I think I want a higher y. Let's try 20 maybe. And then let's graph that. There we go. That's a better picture. And then if I show you y equals, what is this? X plus 2, was that our asymptote? X plus 2, graph that. There's that asymptote. Yeah, that's pretty neat. All right. I'm going to cut it there for a minute so I can let my puppy out. And then I will continue on right after this.